welcome to Making Democracy Work. This is a monthly series brought to you by the League of Women Voters. Each month, we discuss topics of community interest. This month, we're going to talk about the use of local woods, the Albizia project, but not only Albizia, but other local woods.
The Albizia project is not just about the tree. When we change the way we source our building materials, we can go from the exploitation of our planet to the restoration of our native ecosystems.
And we have with us my co-host, Kaui Lucas, and the leader of the Albizia project, Joey
Valenti.
Joey Valenti. Welcome.
Thank you.
And let's talk about the Albizia project. You had the idea, right?
Right.
Mm-hmm.
Started as my doctorate project at the University of Hawaii School of Architecture.
You were an architecture student.
Correct.
And you saw that so much wood is being imported and so much wood is being wasted here. So you put the two together.
Right.
Yes. Mm-hmm.
Yes.
Good. And you have found lots of people to help you?
I have. It started out slow, but since I graduated in 2016, we've been able to leverage enough support and collaboration to build a full-scale prototype at the University of Hawaii Manoa campus. That included cross-campus collaboration from the architecture school to the engineering department, Office of Sustainability, and that also expanded off to private sector, sawmills, woodworking facility in Wahiwa, Bell's Millwork, and the list goes on. So.
Mm-hmm. Maybe we could see a picture of the beginning of this. Kekoa? There it is. That's your concept.
That's right. That was, we call that a digital rendering. So the whole model or structure that you see on campus was built first in 3D with a computer program software, and taken into another software to kind of show what the potential is with this design.
Mm-hmm.
What's been so exciting is to see it go from just being two-dimensional and the little model to here it is. We now have it on the corner of Dole and University, I believe. Is
right.
it?
Very accessible.
Metcalf.
It's University of Metcalf.
Sorry.
Right.
Oh.
Right
Across from the Banan.
Banan, yeah.
Mm-hmm.
That's right. Can't miss it. It's, I think the most fitting location for where it should have been built because right adjacent to it is an architecture school, and outside of that that building is a school's woodworking shop. It's kind of where it started to take shape, and it did kind of grow wings and leave campus to do the full manufacturing, but then it was amazing to see it come back home and kind of take shape there. So
We have some pictures of how this project begins with the Albizia trees, and they're sort of. I love this picture because is that you, Joey? I mean, you're so tiny. Is that person is so
no,
tiny?
No, that's my friend Harvey.
Okay, well, that very tiny person looking in this. So how big are these trees?
Yeah, that gives a nice sense of scale because he's probably about 6 foot tall, and as you can see, you can only get a section of the tree. It goes on beyond the frame of that picture. So they grow in the hundreds of feet. I mean, one of the fastest growing trees in the world, and I believe the largest tree across the islands in Hawaii. So they're monsters.
Now, before we forget what that model looks like, when you had a scale model in the Capitol, was it that or what you actually built?
From the first image.
Yes.
So that was a 3D image, but the first model that was at the Capitol was built based off of the 3D program, and then built with my hands, and then essentially scaled up. We built a second larger model and then full scale more recently.
But the actual thing looks different. What you built, life size, looks different. So did your scale model look like the picture, or did it look like what you ended up with?
It was maybe somewhere in the middle.
I see.
Yeah, because
It's pretty close. That rendering shows there's kind of a montage of images there, but the actual 3D model that they had there looks remarkably close. We have some pictures of you guys actually working on it at the school, and can you talk about that, the way that it took all sorts of disciplines, and we have this idea that if you're studying architecture, you're just it's all 2D and not really working with machines. So tell us about how did this aspect come into it?
Yeah, you raise a good point, Kaui. It's not often that architects get their hands on the actual build of a project, and that was really a lot of my motivation in this project, because I like working with my hands. I love woodworking, and I was trying to find ways to kind of intersect that with my learning through the architecture program. So what you're seeing in that image before was us actually building the full-scale components out of bellows millwork. And that was up at the shop in Wahiwa. And we, those two guys, big guys over there, were also architecture students in the program. Good friends of mine and now colleagues out in the professional in some big firms. So we brought in all kinds of support from architecture, and that woodworking facility was essentially like where all the big parts came together.
Now tell me, was that wood bent or was it cut like that?
Cut like that. So
I see.
It's a bit of an illusion when you look at the structure, when you look at the arches there, and there's a process that we kind of developed for that. And having started the project, not knowing too much about the strength of the wood, I was just kind of on the assumption that it was weak, and that was kind of the general consensus and what people would say. So I developed something very strong in terms of the engineering of the wood. So there's a lot of new technologies in timber construction where they're actually doing like lamination of wood, and they're able to build 10, 20-story buildings now, and it's kind of the new movement is how tall can you build a wood building. So I took some of that literature and tried to bring it to my research, and developed essentially this design based on the assumption that the wood was weak.
Let's see some of those pictures of the finished project. I think we have some.
And so you found that the wood was actually stronger than you had assumed? Oh.
Right. So somewhere in the middle of all this, we were doing some testing specific to that design, but we also wanted to just test the wood versus Douglas fir, which is the industry kind of standard construction grade lumber. So part of the early stages in building this, we had, I led a student course at the architecture school over the summer, and Steve Hill, which was on one of your earlier programs, was my co-instructor, and we had 7 students that helped us to build the first couple of arches, just to see if it was feasible. And during that class, we also did some tests at the lab, dimensioned albizia versus dimension Doug fir, and the tests were remarkably stronger than the Doug fir. And then a student at the engineering department actually did more in-depth research in his thesis, and he did several tests, and all of them supported that albizia is as strong, if not stronger, than Doug fir in structure.
And Douglas fir is what is usually used here, is that right?
Correct. It's the industry standard. It's
I
the
see.
main lumber grade material here.
So you got to work and develop this way of creating these long curved beams that are the structural members on this.
Mm-hmm.
And you worked with who to have all of this happen?
In the manufacturing or in the design? So there's kind of multiple things happening simultaneously. But in the design, I worked with Dr. Ian Robertson, who's the director of the structures lab at the engineering department. He essentially he did all the calcs and helped me to figure out what tests needed to be done to make sure this could work as a building material. But on the other end of it, when we were doing the testing, or when we were doing the manufacturing, that was based out of Bell's Millwork. They generously opened their doors to this project and trained me some of the basics to their machinery, and then essentially said, you can build it yourself. And I hired one of my students from that class before to help me do all the manufacturing.
So now that the albizia project is kind of all grown up and standing there, now that it's there, what are the things that are ongoing with it? Like you had mentioned before about some kind of testings that is being done. Like, what are we learning about it?
Right. Well, the tests, we call it preliminary tests because it's not enough to take it to the DPP, Department of Permitting and Planning, and say, this can be a structural material. So it's enough to say that we are on the right track, and that if we wanted to put funding into this, because it's pretty rigorous to get something like this in the building code, we've proven that it can be. So it's just a matter of what's that next step to doing that test. And the engineering department would essentially hire a student within their program to do those tests if we were able to fund it. So that's something we're going to be looking at over the next couple of years, as well as kind of expanding the palette for this in terms of what other species are available here.
So there has to be a change in the current code to be able to. What isn't code about it?
Well, it's not recognized, so it hasn't been proven in the International Code Council. So to do
is it
that,
the design that hasn't been proven, or
it's
is it
the material itself.
the material itself?
So Doug fir, for example, that's done. It's been through all the tests, so we know what to treat it with. We know what 2x4 strength is. Albizia, it's not recognized, right? So we would have to do some of that to show that. But there is alternative code compliance. So rather than getting it, certified nationwide, we can have it specific to here, which probably makes more sense. Not as rigorous of a process and cost intensive, to where that design at UH, we can prove that it can be built, right? We've done tests, so we can take that information. If we need to do more tests, we can work with the the DPP and see what they would require for us to get that approved.
Okay, and speaking of testing, what about those pesky little termites?
So this one, the one at UH that's standing now, we did a borate treatment, just a surface treatment. So typically you wouldn't do that for an exposed structure where this one's like fully exposed. But we were on a tight budget, tight timeline, so we did it just to make sure it had some treatment. There's a treatment facility on island that we were considering working with, but it just didn't make sense for this first one. So that's something that we would maybe work with them on conducting tests, and then maybe CTAR at UH can get involved or something where we can actually run the right kind of tests to do treatments. But we have talked to experts in the field that have actually found ways of treating it, so we would just have to prove that it's been done and that it works.
They found ways of treating albizia wood?
Yeah,
Huh.
yeah.
So somebody else has been working with it as a building material.
Yeah, this guy on Kauai named Bill Cowern actually worked with it decades ago. So he's the OG albizia kind of innovator, but I think he's kind of gone in different directions. So he still supports it, and he backed my idea early on when he had heard about it and said, you know, you're on the right track. He had sent me a bunch of tests that he had already done. I actually visited him a few months ago, and he has 1 by or 2 by kind of circular posts that he says are 20 years in the ground, and the treatment he used allows it to still be standing. So
Wow.
yeah,
That's
All right.
So,
That's
promising. Yeah.
was it treated with something that's legal?
Yeah.
Okay. Good.
He said, you know, you can do it's just the process that I think is the most important. So he says the best way to penetrate the wood is to treat it when it's green, which means right when you mill it, and then you would soak it like in a tub of the borate, which is like a salt base. So it's not, it's the least kind of harmful environmentally. It's safe for human contact. Where some of the other nasty stuff, it's not even legal now. So there are ways to treat it. And
Are you working with other kinds of wood?
yes. So that question kind of leads to where we are now, and we've teamed up with Department of Land and Natural Resources, Division of Forestry and Wildlife, and we are working on a 2-year federal grant that we were awarded this year, which is just starting now. And with that grant, we have started a Hawaii statewide wood utilization team, and we've also within that team, we'll be leading 3 projects, and the projects are going to be focusing on the timber management areas statewide, which people often don't even know we have, and they're actually at high forest fire risk. So we want to promote the use of those products as well, because the more we can thin these forests and maintain them, the less prone they are to fire.
Tell us about the location and the types of trees.
Okay. The location we'll be focusing on for this grant period initially is the Koke'e timber management areas on Kauai, and that is we were just there earlier this year, and that seems to be mostly eucalyptus and pine, and eucalyptus, I think saligna and grandis are the primary species up there. So that's just one timber management area. There's actually several across the state. Big Island has, I think, the largest. And
Yes, they're planning to burn it. And wouldn't it be much better to use it to build things?
I think so. Support that.
Yes.
Yeah. So what we hope to do is, keep this kind of innovation going and help raise awareness and try to connect the dots between the supply and the demand, and hopefully start to bring more demand to our community, so we're not import reliant as much as we have been. So
What do you see as the main challenges to having the local wood be viable as building material supply? I was at that presentation at the panel where they talked about timber being used for an 18-story building, and I was completely blown away by that. That was quite something. What are the chances of that happening here? Can we do that, or is it not?
No, we can do that. It is impressive, and it's happening mostly on the west coast of the U.S. right now. They're getting their building code up to date on that, and they're allowing it's called mass timber construction. So kind of the engineered wood that I mentioned earlier process is taken to where you can build multi-story structures with this engineered wood product. So that's what we're exploring, is how can we bring that here, and I think it's just a matter of time. And we might not fully become self-sufficient on that. That's something we're going to explore over the coming years, is, what can we use here for what applications, and if, that can be turned into something for mass timber. That's what we're hoping to find out. And if what we have now isn't, then what we plant in their place, we can be more creative and kind of strategic in what those new species can be used for. One of the challenges with mass timber that I'm learning is termite, and treating certain engineered wood products can be challenging. So the good thing is that there's so much momentum and innovation around it that some of the major players in it are saying it's just a matter of a couple more years until they find ways of doing it.
So somehow it's hard to I would have thought that the engineered wood would be easier to treat. Slip it into the glue or something.
Yeah, there are ways of putting it in the glue, but then that's just the glue line. So you also have to figure out how to treat the wood itself, and then there's issues of lamination, and not all engineered wood is glued. Some of it's nailed, so that might be a workaround. Yeah, there's a lot of, I think,
but
ways
aside
to
from that, which might be in the future, right now we are importing tons of lumber, right?
Right.
And so if we could just reduce the amount of lumber that we're importing, that would be a really good thing.
Exactly. And I like to reference the food movement here and how we're trying to do the same thing with our food supply. We don't have to be import reliant. We don't have to, how they say, 5 days without a supply here would basically be all we could last. And I think, people are starting to challenge that and, look at what we can do with what we have.
You referenced the building codes. So right now, if somebody had albizia trees or eucalyptus and they wanted to chop them down and build with them, they could or they couldn't?
Not a permitted structure. So if you want it to be permitted, you have to basically recognize that material specifically. So in a specification drawing, you would mark Douglas fir as that material, or some other building code approved material. So albizia wouldn't work.
But you're working on that now.
We're working on that.
For Hawaii.
For Hawaii.
We don't have that much time left. Let's talk about how bad albizia is for Hawaii's ecology. Now, you say it grows hundreds of feet tall. It's the fastest growing tree. And what is the bad thing about it?
Well, as you've probably seen in news articles and, a lot of the negative stories, which rightfully so should be there, because the tree is not only widespread, but it hangs over communities, houses, power lines, infrastructure. The big removal project at the Line Arboretum was to kind of make room for the natives, because it shades them out and doesn't allow them to thrive. So it's ecological as much as it is a social issue and economic for the state, because we don't have the funds to eradicate it. So
Right. So it's
challenge.
threatening the native forest
Right.
by shading them out. And also, when the hurricane hit the Big Island, because it is so tall, the branches did much damage by breaking off and damaging the power lines and houses and things like that. So this is, not only that can it be replacing imported lumber, but we can get rid of a pest by using it. Yeah.
And we want to be careful and clear on the intention of what the Albizia project wants to do, and it's not about growing more of this stuff or creating a new industry. It's supporting the existing timber industry, which is here. It's just small. So how can we find the right scale and the right applications to kind of capture what's already should be coming out and try to incentivize that removal at the same time. And then at the other end of that, how we can replace what was once there, such as native tree species and plant species.
So that's all part of this new grant that you've received?
Not so. The new grant is actually less about Albizia, and it's more about the timber management areas, which isn't an Albizia problem, but it's a forest fire hazard and all that.
And utilizing it.
So it's kind of two parallel tracks running together now.
Now we need to wind up. We're running out of time. Is there something that you wanted to say?
Thank you for having me, and I'm always happy to share what we're doing. And the Albizia project is generally providing updates through our website, albiziaproject.com, and we will soon be launching a website for the Hawaii State Wood Utilization Team.
So you don't have a website yet for that?
It's under development, so we expect it to launch early next year.
But it's albiziaproject.com. Thank you very much, Joey Valenti and Cowie Lucas, my co-host. And I'm Pearl Johnson. Thank you for watching.